Let's explore one of the most powerful and universal ideas in physics, an idea that explains falling apples, orbiting moons, satellites in space, the tides on Earth, and even how astronomers search for planets around distant stars. This is Newton's law of universal gravitation. Everything begins with a simple observation. Objects fall toward Earth because Earth pulls on them. But Newton pushed this idea much further. He asked an important question. If Earth pulls downward on an apple, could it also be pulling on the moon? And if so, is that the reason the moon stays in its orbit? Instead of flying straight into space, maybe the moon is constantly falling toward Earth. But because it also moves sideways, it keeps missing Earth and stays in orbit. To understand this, Newton studied how the gravitational force depends on mass and distance. He discovered three key relationships. First, the gravitational force increases when the mass of either object increases. Double one mass, and the gravitational force doubles. Second, the gravitational force decreases as the distance between objects increases, but not in a simple way. It decreases with the square of the distance. If you move twice as far away, the force becomes 1/4. If you move 3 times farther, the force becomes 1/9. This is why gravity is very strong near Earth's surface, but extremely weak between small objects like 2 cars or 2 people. And third, the force acts equally between the 2 objects, just as the moon pulls on Earth with the same magnitude that Earth pulls on the moon. Newton combined all of this into one universal idea. Every object with mass attracts every other object with mass, everywhere in the universe. The gravitational force is proportional to the product of the 2 masses, and inversely proportional to the square of the distance between their centers. To make this law work mathematically for the entire universe, Newton needed a single constant, a number that sets the scale of gravitational strength. More than a century later, Henry Cavendish measured this number using a delicate experiment with small metal spheres suspended by a thin wire. By measuring tiny twists in the wire caused by the gravitational attraction between the spheres, he calculated the gravitational constant. This constant is approximately 6.67 times 10 to the power of -11 in Newton meters squared per kilogram squared. Its small value reveals something important. Gravity between small objects is extremely weak. You only notice gravity in everyday life because Earth is so massive. Now let's look at how universal gravitation affects the world around us. The moon orbits Earth because of this gravitational pull. The moon also pulls on Earth, and one of the clearest signs of this pull is the ocean tides. Water on Earth bulges outward on the sides facing and opposite the moon, creating 2 high tides and 2 low tides every day. The cycle repeats roughly every 12 hours and 25 minutes because the moon rises a little later each day. Satellites orbit Earth for the same reason. Communication satellites are often placed in geosynchronous orbits, paths where the satellite takes exactly 24 hours to go once around the planet. From Earth, it appears to stay in the same spot in the sky, which allows consistent communication signals. Gravity provides the inward pull needed to keep the satellite in that orbit. The sun's gravitational force keeps the planets in the solar system moving along their elliptical paths. It also controls the motion of comets. Many comets, like Halley's Comet, travel on long, stretched-out orbits. As a comet approaches the sun, sunlight and the solar wind heat and strip away material, forming the bright tail we see from Earth. Halley's Comet returns every 76 years because its orbit is defined entirely by gravitational forces. Far beyond the solar system, gravity shapes galaxies and clusters of galaxies. It holds billions of stars together in spirals and clouds, and it influences the evolution and future of the universe itself. When astronomers look for planets around distant stars, they rely on gravitational effects, slight wobbles in a star's motion that reveal the presence of an orbiting planet. Universal gravitation connects everything in the cosmos. It explains why objects fall, why planets move, why tides occur, and why galaxies form. It is one of the fundamental principles that allow us to understand the structure of the universe, from the motion of a tiny metal ball in a lab to the behavior of stars thousands of light years away. If you enjoyed this explanation and want more clear and simple physics lessons, make sure to like the video, subscribe to the channel, and turn on notifications so you don't miss the next chapter.